So on R1 I'll be using 1.1.1, one loop back over there. On R2 also I'll be using loop back 222. Or do one thing. Here I'll be using 10.1.0/24 network. On R2, in the lane of it I'll be using 20.1.0/24 network. In the lane of R3 I'll be using 30.1.0/24 network. In the lane of R4 I'll be using 40.1.0/24 network. In the lane of R5 I'll be using 50.1.0/24 network. And router IDs will be different. Like on R1 I'll be using 1111. I mean today I'll be using different router IDs, right? Like in previous class I was using router ID same as the IP address configured on their loopback interfaces, right? But here I'll be using some different router ID. So on R1, sorry, first of all on S1/0 IP address is going to be 12.1.1, and then on its loopback it's going to be 10.1.1. and let's do one thing, let's draw a diagram. Here I'll be using let's say 30's network is also in area 1. Here let's say it is area 1, and here let's say that it is area 2. So this time we are going to implement two different regular areas even without using backbone area. So we will see, or I will show you that okay, by default prefixes cannot move from one area to another area. I mean from one regular area to another regular area if you are not having any backbone area. So it is mandatory for you to implement backbone area along with regular areas if you want to establish communication, or I mean if you want to establish reachability in between two different regular areas, right? So it will be mandatory. So we are going to prove it now. So this is R1. On R1 I have allocated an IP addresses, and then after router OSPF1, router ID is 1.1.1, network 000.245.245.245, and area will be, tell me, 1. Then after we can move on R2 as well. Interface serial 1/0 IP addresses are going to be like 12.1.1.2, then on its S1/1 IP address will be 23.1.2, loopback 20.1.1, router OSPF1 router ID will be network area 1. Interface serial 1/0, 23.1.3, 34.1.3, and the loopback will be, and this time you cannot use that command 000, is not it? Router ID is going to be 333. Then interface serial 1/0 IP OSPF1 area will be 1. On its loopback will be area 1. On its serial 1/1 it will be area 2. Show IP OSPF interface brief, is not it? So it must form neighborship see with R2. So it has formed. Then you can move on R4. You can enable OSPF on R4 as well. First of all, allocate an IP addresses interface S1/0. IP address will be 34.1.4, and on its S1/1 IP address will be 45.1.4, and in its lane I'll be using 40.1.1. Router OSPF1 router ID is 4.4.4, network 000, area will be 2. So now you will see that on all interfaces of this router area 2 will get enabled. Finally, let's move on R5. S1 by 0 IP address is going to be now 45.1.5. Oh, sorry. 50.1.1. And here Dr. Ospfpart, Dr. ID is 5.5.5 network. Now, if you move on R3, R3 is a center point actually. Or R3 is a shared router for area 1 as well as area 2. Means R3 is connecting with area 1 as well as area 2. Now the thing is, it is having neighborship with both of them, as you can see here. Like R3 is having neighborship with R2 and as well as R3 is having neighborship with R4. Now this R3 must maintain its database table. Yeah, it is. It is having database table of area 1 as well as
area 2.
Fine. Have it generated any summary LSA here? Or is this router working as an ABR?
No.
Because if it is working as an ABR, then it must have specified here that okay, it is working as a area border router. Are you getting a point or not? Fine. Then after, you can check its routing table. It must have all routes available. See, 10, 20, 30, 40, 50, all of them, and all of them are coming as intra area. And this router is having all these prefixes inside its own routing table because of it is working in both areas. It is participating in both areas, but prefixes will never move from one area to another
Area.
Like if you move on R1 and if you configure show IP route command, only 30 is prefix is there. Show IP OSP of database, it will be having database of area 1 only. So how many routers are participating in area 1 now? 3. So it is having 3 router LSAs. Are you getting my point or not?
Yes.
So in this way, it has proved that by default prefixes information will never move from one regular area to another regular area without having an ABR. So is there any question related to it now? Fine. How can you solve? I mean, let's say that I want that they must exchange their routes with each other. So what should we do now? How?
As you said in
No ABR and ASP.
ABR, but use different processors and redistribute them in R3.
Exactly. I think I have already discussed this methodology with you theoretically, not practically, right? So today, I mean, now I'm gonna to perform that practically. That I said that if you are having 2 different regular areas, they are connected with each other without having backbone area, without an ABR. So by default, prefixes can move from one regular area to another regular area. But the thing is, like, by having backbone area, you can solve this problem. And if you cannot have backbone area, then you can use redistribution. Here I can achieve this task. I can solve this problem by performing redistribution as well on R3 itself. What will we require to do here on R3? Let me remove this process from here. Let me do it. Router OSPF, let's say 1, process 1, right? Then router ID is like here, let's say 3.3.2.1, or let's say 3.3.3.3. Then interface serial 1 by 0, IP OSPF 1, area is what? 1. then loopback 1 will also be in area 1. It has formed neighborship with R2. Now router OSPF run another process of OSPF on the same router. Let's say it is 2 and router ID is like 30 30 30 30, something like this, and then go to interface as 1 by 1 IP OSPF 2 area is what?
2.
So it must form neighborship with R4 as well, and now again all routes will be available in its own routing table as intra area. But now the problem, problem is that prefixes cannot move from one process to another process, and if you want them to put from one process to another process, then you have to perform redistribution. To configure redistribution here, the command will be very simple: router OSPF 1, and then you can say redistribute OSPF 2, and then you can also specify subnets keyword. Then you can move under router OSPF 2, and then you can say redistribute OSPF 1.
Subnets.
Now this router will become exactly ASBR. Is not it that another process is also there, one in it also it is working as an, and you are redistributing external out from OSPF 2, is not it? So this time you have performed redistribution here. So R1 must have all those prefixes here. R5 must also have those prefixes here. From R5, what happened? Light. Have you understood it?
Yes, sir.
That how can we solve this kind of problem? By just using multiple processes on border router, and on that border router use separate process for each area and then perform redistribution. Redistribution is not possible from one area to another area. Redistribution is possible from one process to another process only. Even if you are using same area, here area 1 and here also area 2, area 1, in both direction you are using common area, but on R3 you are using two different processes, then also routes will not go from one process to another. Hello. By default there is a rule in OSPF that prefixes cannot move from one process to another process. Does not matter whether you are using common area or not.
Yeah.
Even in place of area 2 you can implement area 1, but then configure multiple processes on R3 itself, and you will find that prefixes will not go from one process to another process automatically, without performing redistribution. So if you want to take prefixes from one process to another process, then it will be mandatory for you to perform redistribution. Tell me, if you do not want to perform redistribution here on R3, do one thing: no router OSPF and no router OSPF 2 as well. So I have removed both areas, both processes from here. Do show IP OSPF neighbor, it does not have any neighbor. Do show IP OSPF database, it does not have anything inside its own database. Now say router OSPF only one, process ID 1. Now router ID is what? 3.3.3. then interface S1 by 0. IP OSPF 1 area is what? Area is what? 1. Then interface S1 by 1 area is what? And then loopback 1 area is 1. Once again you will see that prefixes will not go from one area to another. However, this time you are using common process for both areas here. Fine. After it, on R3 itself, if you want that, okay, they must, these areas must exchange their routes with each other, make it ABR, and to make it ABR it must have at least one interface in backbone area. So you do one thing, create one another loopback, let's say loopback 10, or you do one thing, do not create any extra loopback, just put its loopback 1 itself in area 0. Like interface loopback 1 IP OSPF 1 area is what? 0. Once you will put this loopback in area 0, now it will become an ABR. Let me show you that it have become now ABR. Show IP OSPF. So once you will configure this command show IP OSPF, it will show you that it is working as area border router. And then after, you will start to see here that show IP OSPF database. Now it will start to maintain the database of area 0. It is having only one router, let's say in area 0. Can you see that?
Yeah.
It is having only one router, let's say in area 0. You know why? Because only one router is participating in area 0. That is R3 only.
Yeah.
And only one link was there in area 0, which was loopback only. That is why it is showing you only one link under its router, let's say of area 0. Then some real LSS are there, then it is also having the database of area 1 as well as area 2, and also it is having some real LSS for those areas. What does it mean? That now if you move on R1 and if you check its routing table, all prefixes will come as inter area. Even if you move on R5 as well, then also you will find all prefixes are coming as inter area. Have you understood my point?
Yes.
That you have two solutions of it, either make it ABR or ASBR, perform redistribution. But redistribution can be done after using two different processes. Fine. Now I wanted to make you understand something related to network types as well. In previous class I taught you that how to change your network type on serial interfaces. Even on serial interfaces as well, I configured its network type as broadcast, and on Ethernet link I configured their network type as point to point. Today I will prove you that if you are having more than two routers in a multi-access network, and then after if you configure the network type as point to point, what can happen, right? So let's do one thing. Let's take one switch here. And now what will I do? I will be using their fast Ethernet 0x0 here of R4's Ethernet 0x0 as well as R5's Ethernet 0x0 will also be connected with this switch. So now in this multi-access network, how many routers are there? 3. And this is a common multi-access network, is not it? And now I'm gonna to allocate an IP addresses here. Like what will I do on R4's FA0 by, on all routers FA0 by 0, I'll be allocating IP address in this way. Like, tell me. 192.168.1.1. On R3, 192.168.1.3. On /24. On R4 it will be 1.4. On R5 it will be 1.5. Understood? Fine. Let's move on R3 now. One dot. And IPOSP1 area is what? 2. Then I will move on R4. 1 dot. On R5 also. dot 5. Understood? Fine. Let them elect their DR and BDR now. On R3, I'm gonna run this command try to Ospfpart neighbor. You see that R5 have been elected as a DR because R5 was having highest router ID, and all of them started to participate in OSPF within a time period actually. Like if you enables OSPF on other routers before expiration of wait interval, then all of them would participate in the election of DR and BDR. So this time you can see that R5 has been elected as DR, whereas R4 has been elected as a BDR. Now let me do one thing. On R3, I'm gonna to shut down its S1 by 0, its S1 by 1 as well. I have shut down it now. So this time this R3 is having neighborship with R4 and R5 with using Ethernet connection only, and DR BDR election is there. Now what will I do? I will configure their network type as point-to-point on all devices. Like on R3 is FA0 by 0, I'll say IP Ospfpart network type is what? Point-to-point. In same manner, I will move on R4. I'll configure its network type as on R5 also. Network type is what? Point-to-point.
So what it will happen if we change the priority as 1 from 0?
Okay, you said, I mean, you wanna say that if we configure its priority as 1, even we are using its network type as point-to-point, right? What will happen? In case of point-to-point, there is no election of DR and BDR. Let me show you. Interface FA0 by 0, IP Ospfpart priority is what? 1. Then go to R4, configure, go to R3 as well. See, and if you say debug IP Ospfpart adjacency, you understand? See, oh god, ignore due to unknown. Neighborship is not there, but it is getting update from there. So you understand what I mean to say, that it is, I mean, in this way problems can occur if you have configured the network type as point-to-point and if you are having more than 2 routers. Now do one thing, have only 2 routers in this multi-access network, and to have only 2 routers, what can we do? We can move on R3 and we can move on R5, and on R5 I can shut down its FA0 by 0. Just shut it down. There will not be any problem. Now R3 can form neighborship with R4 without any problem. See, and it will not go down. Even you can learn. See, tell me, you are learning prefixes from 1.4. So I hope that now you have understood that what type of problem, what can happen in your network in case if you are having more than 2 devices in a multi-access network, and if you have configured the network type as point-to-point. So if you are having an issue, please let me know. Fine. I'm gonna remove it now once again. Fine. So on R3, on its S1 by 0, on S1 by 1 also, on FA0 by 0, shut it down. On R5 also, sorry, on R4 also shut it down. Fine. Again, I'm using the older network now, right? So, but this time area 0 is existing in between area 1 and area 2. Let's do one thing. This time let's change this diagram once again, so that we will require to have, tell me, virtual link. This time in this case we are not required to have virtual link, and before going to configure virtual link, let's configure some other things as well. Like, let's say that you want to configure static neighbor in between R1 and R2. By default their network type is what? Point to point. Let's say you want to configure static neighbor, or you want to send unicast update messages, or unicast messages, unicast packets, unicast Ospfpart packets towards your neighbor. So if someone have asked you to send only unicast Ospfpart packets towards your neighbor, then you have to configure your neighbor statically. So now go to Ospfpart1, say neighbor is 12.1. What is it saying? So in case if your network type is point to point, then your static neighbor is not allowed. Understood? Even if I configure the network type as broadcast as well, let's say this is S1 by 0, then I'll say IP Ospfpart network type is what? Broadcast. Then I will move on R2, on its S1 by 0, IP Ospfpart network type is what? Broadcast. Then they will form neighborship, they will elect their DR and BDR, let them elect their DR and BDR. Just wait, it have came up now, right? Fine. Show IP Ospfpart neighbor. Who is DR? 2, because 2 is having higher router ID. Fine. Now if you want to configure neighbor statically here, you set neighbor. So remember that in case if your network type is either point to point or broadcast.
Even point to multiple.
Wait. Whether it is point to point or broadcast, you cannot configure neighbor statically.
Yes.
Even in point to multi-point also, you cannot configure your neighbor statically. Are you getting my point or not?
Yes.
Now if you are having hub and spoke topology somewhere, then you will always prefer to configure point to multi-point only. Your network type as point to. See, remember that if you are going to implement Ospfpart in hub and spoke topology, like here also I can design that type of topology. Like, let me demonstrate it on pint. Let's say this is R1 and this is R2, this is R3, this is R4. Now the thing is, like, you want that R1 must form neighborship with R2, then R1 and R3 must form neighborship, then R1 and R4 must form neighborship, but R2 and R3 must not form neighborship with each other. Then you have to use their network type as point to multi-point. I mean, in this kind of situation, in this kind of network, you can configure your network type as point to multi-point. So if you are going to implement this OSPF over NBMA non-broadcast multi-access over NBMA, and if you talk about the NBMA address, NBMA networks, non-broadcast multi-access networks, your NBMA networks can be either fully meshed networks or hub and spoke or partial mesh, right? So if you are having your NBMA topology as, or NBMA network as hub and spoke network, hub and spoke topology, I mean if hub and spoke topology is there, then tell me, if hub and spoke topology is there, then you must use your network type as point to multi-point. And if you are having NBMA network as fully meshed network, then you must use either broadcast or non-broadcast. Because you are talking about NBMA network, then you have to use your network type as non-broadcast only, not broadcast. I will teach you all these things during DMVPN. I'll teach you all these things during DMVPN only, dynamic VPN, because here we are not having frame relay. In place of frame relay, now because frame relay is not there, it means we do not have NBMA, but it's not true that we do not have NBMA. Even DMVPN is also known as NBMA, non-broadcast multi-access. So I'll be configuring, I mean first of all I have to teach you DMVPN, and then after I can go for this network type. However, I will teach you that how can you configure all these things, right?
Yeah.
So let me show you how. And the actual effect of this command, you will go through this command, or you will go through this configuration during DMVPN only. So whenever I will go for DMVPN, then I will teach you that okay, in this way you can use this network type point to multi-point, right? But here at least I will tell you that how to configure it, right?
Yeah.
But remember that you will be using this point to multi-point network type in that case where you are having your topology as hub and spoke topology. Let's move back again on R1, and if you want to change its network type, then go to serial interface 1/0 once again, and say IPOSP network type is what? Point to multi-point. So in this way you can change their timers, and this time you will see that their neighborship will not come up. In case of point to point and broadcast, neighborship can come up, but routes will not get exchanged. But in case of point to multi-point and broadcast, even neighborship will not come up. Even in between point to multi-point and point to point also neighborship will not come up. You know why? Because in case of point to multi-point, your timers will become like 30 and 120.
Yeah.
Whereas in case of point to point or broadcast, its
10 and 40.
timers, I mean their timers will be 30 and
40.
sorry 10 and 40, 10 and 40, right? So this time of course their neighborship will not come up, but you know, if you change its timers like IPOSPF,
Hello. 10, 13, 14. It will come. Yeah.
and this time see what is happening. It is showing me that it is BDR, but now this R1 will not be as BDR longer. You know why? Because its on priority will become now 0, because if you have configured network type like show IPOSPF interface serial 1/0, you configured its network type as point to,
Multi.
and in that case priority will become 0 automatically. It will not be longer eligible to become an BDR now. To become BDR. So that show IPOSPF neighborship is there, routes are not there. Have you understood it now? Now do one thing, interface serial 1/0. Even you can remove all these previous commands from here. Once again it will break its neighborship. Show IPOSPF neighbor. You have to wait for the expiration of that interval, right? Or you can say one thing, clear IPOSPF process. Then after again you can move back on R2, and you will see that neighborship will not come up. See, just wait. See that timer has reduced than 30 seconds, and if that interval has been reduced than 30 seconds, it means it is gonna to break its neighborship after, because if it is receiving periodic hello packets, it means after 30 it should have started from 39 itself, but this time it will break neighborship after 10 seconds now, right? So it is going to break its neighborship with R1 because on R1 you are using different timers. But you do one thing, move on R2 as 1 by 0 itself, and then say IPOSPF network type is 0.2 multi-point. So IPOSPF neighbor see and there will not be any problem related to routes as well. So I hope that you have understood that how to change their, how to manipulate their network types. Then after router OSPF1, say neighbor 12.1.2, still you cannot configure neighbor statically. Has proved or not?
Yeah.
So again it has proved that in this network type as well we cannot configure our neighbor statically. Then let's do one thing on R1 itself. This time because we want to configure our neighbor statically, so let's configure the network type as non-broadcast only, right? So interface as 1 by 0. IPOSPF network type is what? 0.2 multi-point, sorry, simply non-broadcast. And then after I'll go for 0.2 multi-point non-broadcast, right? So this time I have configured non-broadcast. Then you do one thing, move on R2, serial 1 by 0, IPOSPF network is what? Non-broadcast. And this time let me capture this link as well. I will show you that all packets of OSPF will be unicasted now. Even they are not sending hello packets to each other automatically, dynamically, because they cannot form dynamic neighborship now. In case of network type non, okay, I think I have already configured it. Yes, that I think that command was already configured here. Do show run pipe section router. Sorry. I think I configured that command here. No.
सर ये non-broadcast में भी dynamic discovery होती है.
Not non-broadcast. Let me show you. In non-broadcast, your neighbor cannot be discovered dynamically. You have to define your neighbor statically in this way. See, router OSPF1 neighbor 12.1.2. That's it. Just you are required to configure this command only on one end. Then after you will see that your neighborship will come up automatically. Let me show you. Show IPOSPF neighbor. It is still in two-way state. Of course. In case of non-broadcast, again DRPDR election will be there.
Yeah.
You have everything in your written. I taught you everything, all these things before. I have already taught you all these things before. Just go through those documents.
Only in broadcast and non-broadcast we have DRPDR.
So this time, just wait for a moment. It has to do, we have to do wait for the expiration of wait interval. After the expiration of wait interval, DRPDR election will be completed, and now you see that neighborship is just about to come up. But remember, if you do not configure your neighbor statically, then your neighborship will not come up. So run pipe section router OSPF, as you can see here. Right? So it is also not mandatory to configure this neighbor command on both sides, but it is mandatory to use the same network type on both ends. So I hope that you have understood that why do we require to configure its network type as non-broadcast. So wherever you will require to configure your neighbor statically, wherever you will require to send unicast updates, unicast OSPF updates, and along with DR and BDR, then you have to use your network type as non-broadcast. And if you just want to configure your neighbor statically, but you do not want to let your routers to elect DR and BDR, then you can use your network type as 0.2 multi-point non-broadcast, right? So let me configure that now. So interface S1 by 0, say IPOSPF network type is 0.2 multi-point non-broadcast. broadcast. In same manner, I will move on R2 on its S1 by 0. I will say IP OSPF network type is 0.2 multi-point non-broadcast, and then after I will show you that neighborship will come up. Show IP OSPF neighborship is there. It must have all routes as well. Or you do one thing, please say clear IP OSPF process once, and then after say show IP route. Is not it? So this time there will not be any DR and BDR election, but still you will require to configure your neighbor statically. As you can see that we have already configured this command here. We already configured this command here that neighbor is 12.1.2, right? So remember that neighborship will not come up until you configure, unless you don't configure neighbor command.
So even if we connect with fast Ethernet link, this is the same process.
Of course. That's why that's what I mean. I want to make you understand that it is not always necessary that you can use network type broadcast only on Ethernet connections. Wherever you want, you can enable it, but as per requirement. Even in live networks, in production networks, you will see that if you are having only two routers connected with the Ethernet segment, then you will always prefer to use point-to-point only in place of using in place of using broadcast or any other thing. So I hope that now all these things are okay for you. Is it?
Yes.
Network type is done now.
Yes.
That how can you configure neighbor statically, and now you can also do one thing. However, it is not possible here. Like router OSPF1, and then you can say neighbor 12.1.2 and then cost. Okay, for this neighbor, I have defined its cost as 50 now, and now you see show IP route to reach R2's lane network, which is 20's network. Where is that?
1.1.1.2/32.
See 51. So this time it will not add the cost which is configured on its own interface. Let me show you. Show IP OSPF interface serial 1/0. What is the cost of this interface? And however it is receiving updates on this interface from this neighbor. Hello. So it should have considered the cost of this interface only. Are you getting my point or not? So in case if you have configured your neighbor statically, then also you can change the cost per neighbor basis. You know why this option is there? Because might be possible that on a single interface you are having multiple neighbors, but you want to modify the cost only for a specific neighbor, not for all neighbors. Because if you change the cost of the interface, then it will be effective for all neighbors. Let me show you. Let me prove all these things. Let's say, guys, this is R1, this is switch now, this is R2, this is R3, this is kind of multi-access network. And now you have configured this R1 as a DR because it is working as a hub. These all are spokes. Now the thing is, R1 will be having neighborship with R2, R3 as well as R4. Now R1 is receiving same prefixes coming from R2, R3 and R4, but it wanna preferred via R2. So you are required to change your cost to achieve this task. Now you are having an option to change this cost on R1's this interface, right? FA0/0. But if you change the cost on this interface, then it will be applicable for all those neighbors. For all these neighbors, R2 as well as R3 as well as R4. But if you wanted to change it only for R3 and R4, then you have to change your cost per neighbor basis. But this command cannot be configured if your network type is broadcast. This command can be configured in that situation only where you have configured your neighbor statically. If you have not configured your neighbor statically, then also you cannot use this command to modify your cost per neighbor basis. That's why I said here that if you check the interface of R1 like show IP OSPF interface serial 1/0, you can see that its default cost is what? 64. But here show IP route 20.1.0, 20.1.1 because loopback is there, right? So what is the cost to reach it? 51 because 1 cost 1 is there for loopback interface itself. As you can move on R2, you can see show IP Ospf interface loopback 1. So by default cost is what?
4.
And then it is adding its own cost as 50. So total cost have become now 51. Have you understood it or not? So in this way you can also modify your cost per neighbor basis as well. Now I have taught you all these things. After it, let's start to modify your timers as well. That how can we modify timers? We have already gone through all network types and all these basic things, right? That how do they perform DR election, how can we manipulate it, right, by modifying its priority and all these things. But remember, in Ospfpart, once your DR has elected, it will always remain as DR. There is no preemption available for DR election. It is not like that, let's say BDR have become now DR and now DR have came up once again. So it does not mean that once again that old router would become DR in your network. No, because there is no preemption available in Ospfpart. Once a router have become DR, it will always remain as DR until it goes down.
सर एक आपने ये दिया अभी का वो करवाया तो उसमें करेक्शन है जो उस दिन देख रहे थे ना एक्सटर्नल रूट की जो मैट्रिक्स 0 आ रही थी वो सिर्फ इस वजह से आ रही थी क्योंकि वो लूप बैक था और आरआईपी से रीडिस्ट्रीब्यूशन हो रहा था। अगर हम किसी और से करवाते हैं आगे का राउटर हो जो तो उसकी मैट्रिक आती है हमेशा 0 नहीं रहती।
ओके 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 ओके
जो मैट्रिक आरआईपी की होगी उस टाइप
ओके 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 ओके
देखा था मैंने।
but in case of ESGRP, I think it will not work in that way.
नहीं ये याद नहीं कर रहा
ESGRP में मैट्रिक लेकर के आ रहा था वो वाली पुराने वाली।
उस दिन हम 0 देख लेते ना एक्सटर्नल डाटा के नीचे उस रूट के लिए।
Have you guys understood it? He said that in ESGRP, but you should have this. So I hope that now you have understood all these things, that how can you perform all these type of practicals, right? After going through all these things, let's go for that how to modify your timers. As you know very well, hello interval and dead interval, and if timers do not match, your neighborship will go down. Is it necessary for me to go for configuring timers in Ospfpart now? I have already configured both commands, hello interval as well as dead interval, and you must understand the uses of hello interval as well as dead interval, right? Then after it, let's do one thing. Let's talk about that how can we modify the cost of the interfaces as well. Like show IP Ospfpart interface serial 1 by 0. If you want to modify the cost of this interface, you can modify its cost by using this command IP Ospfpart cost, and then you can configure whatever you want. However, that cost was calculated with the help of formula, but this time if you configure any cost, then it will manipulate that automatically calculated cost, right? Like here, if you have configured it as 100, then it will always show IP Ospfpart interface serial 1 by 0. It will show you that its cost is now 100. So in this way you can modify the cost of link, cost of the interface, just to manipulate your path selection, right? Then interface S1 by 0, just remove this command. Apart from it, you can also change your cost calculation formula. As I said, that if you are having any link which is having bandwidth more than 100 Mbps, then the cost will remain same for all type of links, for all links, whether it is 1 gig, 10 gig or 40 gig or more than that. So now to change that, actually you can see that by default its formula is what? So IP protocol, you can see here that by default its reference bandwidth is what? 100 Mbps. So IP Ospfpart interface serial 1 by 0, by default its cost is 64 because bandwidth of serial interface is 1.544.
Yeah.
So if you divide your 100 by 1.544, then it will come 64. It will become 64. Now the thing is, if you wanna modify your reference bandwidth, remember that your reference bandwidth should be equal to that bandwidth which is the highest one in your network, which is highest one. Let's say that you are having highest bandwidth available in your network as 10 gig or 20 gig. So if you are having highest bandwidth as 20 gig or 40 gig, then you have to configure your reference bandwidth as 40 gig. So it will be depending on the available highest bandwidth. So router Ospfpart 1, and then you can say auto cost reference bandwidth, and then you can make it like I have made it 100,000, which is which is
152.
because it is in case of it is in form of Mbps actually.
Yeah, 100 Mbps.
So if I'm saying only 100, it means 100 Mbps. If I'm saying 1000 Mbps. If I'm saying 10,000, 10 gig.
10 Mbps.
If I'm saying 40 gig, then I have to say 40,000. Show IP protocol. So let me show you now. It will become 40,000 Mbps. So for the link of 40 gig, for the link of 40 gig, the default cost will be 1. But if there is any other link which is having bandwidth of 10 gig or 20 gig, the bandwidth will be, the cost will be different. Hello.
Yeah.
By using this command auto cost reference bandwidth, you are changing the default cost calculation formula of Ospfpart, because this formula will get failed wherever or whenever you will start to have links of bandwidth higher than 100 Mbps. So in this way you can change it. Then after you can see show IP Ospfpart interface serial 1/0, and you will see that the cost is now 25906. If you check the cost of show IP Ospfpart interface, see its bandwidth is 10 Mbps. That is why cost is now 4,000, because you will divide 40,000 by 10. You will divide 40,000 by 10. That is why it have become now 4,000. Reference bandwidth. So I hope that you people have understood it now, that how can you modify your cost of the interfaces by modifying your reference bandwidth. How can you modify the cost of your interface by configuring cost itself on the interface. How can you modify your cost per neighbor basis as well. But per the neighbor command is yeah, of course, like if you are not configuring your neighbor statically, then you cannot configure that command, that neighbor, and this is cost for this neighbor, right? So make sure that, there are some limitations for neighbor command actually. So you must remember all those limitations. Then after it, because we have performed all these things here, next is going to be that how to configure authentication in Ospfpart. As you know very well that Ospfpart supports 3 types of authentication.
Null authentication.
Are you getting my point or not? It supports 3 types of authentication now, which is by default plain text type 1
and
and MD5, which is type
3.
2. So now let's go and configure this authentication here on R1. It is very simple. Interface is 1/0. If you want to configure plain text authentication, the very first command will be IP Ospfpart authentication and enter. To enable this command is used to enable type 1 authentication onto this interface of this router, right? Then after it, next command will be IP Ospfpart authentication key Cisco. Show IP Ospfpart neighbor. See, it is sending hello packets from 12.1.1, and you will see that it will be having now authentication field over there. Inside the Ospfpart header itself, simple password and your password. Next hello packet, even you can also find your password as well. Right? So this is the plain text actually. So this time you can see that it has to break its neighborship now. Now let me do one thing. Let me configure its network type as IP Ospfpart network type is what, point to point. In same manner, I'll move on R2. I'll make it now. So it must form. It is not going to form neighborship because due to mismatch of authentication or authentication mismatch. You can say debug IP Ospfpart adjacency, not adjacency, actually you have to say events. debug IP OSPF events will show you that okay, why OSPF neighborship is not coming up, right? So this time you can see that mismatch authentication type input packet is specified 0, whereas we are using type 1. So now you have to move on R2 and you have to configure same authentication type and authentication key on R2 as well. So move on R2 S1 by 0. IP OSPF authentication key is what? Even now neighborship will not come up. However, key is matching, but still on R2 you have not enabled type 1. To enable type 1 authentication, this command is really important. It's mandatory. Now you will see neighborship will come up. So sometime you will see that key will match on both ends. Key will match on both ends, and you will simply look at only key. You will not look at that command, that whether this type of authentication is enabled or not enabled. So NT shoot actually might be key will be same and will be configured on both ends, but type will not be enabled on any one side and will mismatch, and also neighborship will not come up. Have you understood it or not? So this time you are using plain text, and let's move again back on R1 and let's say we want to configure MD5 authentication. So command will be IP OSPF. Authentication is what? This time I wanted to use message digest. So message digest will get enabled, and then IP OSPF message digest key MD key 1. I have taken key 1, and you can take any key in between 1, 2, 2, 5, 5. I have taken 1 MD5, and then your password is, let's say, Cisco 123. Once again it should break neighborship, and you will see that it will break neighborship after 6 seconds. After 2 seconds it will generate log message. Now it has broken its neighborship, right? Debug IP OSPF events. Once again it will show you that it has broken neighborship due to mismatch of authentication type. So we are using type 2, whereas input is specified with type 1. So you do one thing now, go to R2, now say IP OSPF authentication message digest 1 MD5, sorry, IP OSPF message digest key 1 MD5 and Cisco at will not come up because still type is not enabled. I'm just doing wait. So neighborship is not coming up. So because neighborship is not coming up, I have configured now this IP OSPF authentication message digest command as well, and now you will see that neighborship have came up. Let's move back again on R1. See, and this time hello packets are containing your data, and this is your data, this is your password. Key ID is still there, right? Is not it? Now in iOS 15.3 or in iOS XE, you are also having one another type of authentication which is known as cryptographic authentication. Which is known as cryptographic authentication. There is no type for them. You are having type field only for null. I mean these three types of authentication you are having your type, like type 0, 1 and 2. But for all those type of authentication you do not have any type field, right? Any type specification. So now they have launched one new type of authentication which is known as cryptographic authentication, in which you can configure keychain. Means that in OSPF now, in iOS XE or in iOS 15.3, you can use keychain to configure authentication in OSPF as well. And the commands will be something like this: keychain test key 1 Then you can also configure send lifetime, accept lifetime, same as ESGRP. They have included this option, this feature in OSPF for rotational keys. Previously, it was not possible to configure authentication in OSPF with using keychain, but now in new iOS or in iOS XE, it is possible to configure keychain in OSPF as well. After configuring key 1, you will say key string, which will, let's say, Cisco exclamation 1 2 3 4 5 or whatever it is, right? Then after you have to say cryptographic authentication. Cryptographic, this command is not supported by this router. Even I'm also having iOS 15.2, but it is not supported by 15.2 as well. So you will say cryptographic, and then you will press question mark. It will show you, it will list it all cryptographic mechanism, all cryptographic types, you can say. Like over there you will find SHA, MD5, HMAC SHA with bit 252, then 128 as well, 64 bit is also there. So it will be depending on you that what you select over there. But remember that on both sides this cryptographic type must be same. This cryptographic mode must be same. If you are using here SHA HMAC 256, on another end also you have to use SHA HMAC 256. Are you getting my point or not?
Yes.
So in this way you can define your cryptographic mode, and then after go to simply your physical interface like serial 1 by 0, and then say IP/OSPF authentication, and then over there you will find this keychain option, and then your keychain name is what? That's the only thing that you will require to do. You will require to configure in OSPF during cryptographic authentication.
सर इसमें keychain तो support कर रहा है, but वो उसके लिए अलग है।
What? Keychain was also supported previously during ESGRP as well. हाँ था keychain तो वही है ना. Understood? So in this way you can configure cryptographic authentication in OSPF. This is the new feature added in OSPF actually, or you can say in version 5. Apart from it, we are having all other commands same as previously, right? Fine. After it, let me tell you some other commands are also there. Like you can also enable your authentication type globally as well. Per area. Like in this way. Like if you move on R2, router OSPF1, you said area 1 authentication. Now you can press enter here. If you press enter here only, then it will enable only plain text. And if you say message digest, MD5. Now what does it mean? That authentication type message digest has enabled on all those interfaces which are participating in area 1. On all those interfaces which are member of area 1, this authentication type will get enabled. So this time MD5 will get enabled on its interface serial 1 by 0 as well as 1 by 1. It means that R2 is going to break neighborship with R3 as well this time. But remember that if you have enabled your authentication type globally, and then after you also specified your authentication type under interface mode as well. So the command which you configure under interface mode will overwrite this one. Will overwrite this globally configured authentication type. Should I repeat my line? If you have configured your authentication type globally as well under interfaces, so the authentication type which you configured under interface mode will overwrite this configuration. What? But depends that virtual link interface is participating in which area. But in area 1, I mean virtual link will never occur in area 1, don't worry. Area 0. Don't worry, I will discuss it with you. Don't ask any question to related to virtual link over here. So I have taught you now that how can you enable authentication globally as well, but still keys will be configured under interface mode only. You cannot configure your keys in global router mode. Is there any problem? So now after it, because we have covered a lot of things from OSPF now, small things, but these small things are really important for you to understand, right? Let's go for multi-area OSPF now once again, in which we will require to configure virtually. I mean, let's configure discontiguous areas now. Let's configure discontiguous areas. Do you understand the meaning by discontiguous areas?
Yes.
Sure. Like, what will we do? I'll be using here area 0. Here I'll be using area 1. And here I'll be using area 2. Twenties network will be in area 0 itself, but our 3's lane will be in area 1 and 40's will also be in area 1, whereas this 50's network will remain in area 2 and this 45's network as well, right? So I'm gonna to draw this, I'm gonna to use this topology in this manner this time. So I have to remove OSPF from all devices first of all. Fine. In area 0 only. Right? Move on R3. On R4. Fine. Now let's move back again on R1. Check its database table. So it is having database, the database table of area 0 only, in which it is having router LSs, 2 router LSs, because only 2 routers are participating in area 0. Then it is also having some summary LSs, because of course routes can come from area 1 to area 0. So when routes are coming from area 1 to area 0, of course they will come as type 3 LSA, right? So you can see show IP route. It is having all routes up to 40's network, but it does not have anything related to 45 and 50's network. Like you can see IP route 45.1.0, or show IP route like 50.1.1.1 as well? Nothing. Even if you move on R5, if you check database table of it, it is maintaining the database table of of area 2 only. And inside area 2, you know very well that only 2 routers are participating. Is not it? So 2 router LSAs are there, nothing else. Show IP route. Now we are not having anything here. You do one thing, move on R1. You do not have route, right? So how can you solve this problem now? Please let me know.
By using virtual link.
By using?
Virtual link.
Wow. Except, apart from virtual link, is there anything else? So that we can solve this problem. Just think about it.
And redistribution. Redistribution.
How?
Create.
We can perform redistribution on R4. So that routes can move from area 1 to area 2 as well as from area 2 to area 1. But why will you configure redistribution if it is not necessary over here, right? So it's not necessary to have, you understand what I mean to say? And one more thing I would like to tell you here. On R1, router Ospfpart 1, no network. Do one thing, interface S1 by 0, IP Ospfpart 1 area, loopback 1 also area 0, fine. Once again there is no problem. All routes are there except area 2's routes, area 2's prefixes. Now what I did, loopback 11, IP addresses are something like 192.168.1.1. My God.
Already.
Go back to 3.3.1, right? 4.4.1, 5.1. Router, RIP, let's say. Version, doesn't matter, don't worry. See, it will convert it automatically. Now I'll say router Ospfpart 1 redistribute. Fine. It would become an ASBR now, right? Do you remember the role of type 4 and type 5 LSS?
Yeah.
I told you.
Yeah.
The uses of type 4 and type 5 LSA. This time because ASBR originally is existing inside area 0. So of course in the database of area 0 there will not be any requirement of having type 4 LSA.
Yeah.
Because all routers which are participating in area 0, they will get the router LSA of R1 itself. So because whenever R1 will generate its own router LSA, it will specify E bit. Do you remember?
Yes.
To specify that okay, I'm an ASBR.
Yeah.
So R1 will automatically announce that okay, I am an ASBR. So R2 will come to know that okay, yeah, that's true, that R1 is saying that okay, it is an ASBR. So yes, it is an ASBR. And along with that, R1 have also originated some type 5 LSAs now.
Yeah.
Let me show you.
Fine.
So IP Ospfpart database, and these type 5 LSAs will never belong to any area. Do they belong to any area now? See, under router LSA they have specified area 0. Some real LSAs also they have specified area, but Do type 5 LSAs belongs to any specific area now? No. Is there any type 4 LSA? No. Advertising ID is the router ID of ASBR, which is R1. Link ID will be containing your prefix information, prefix ID. In same manner, you can move on R2. Show IP route, they will come. I mean, external prefixes will come here. So all these 182 prefixes are available here, right? And then you can see show IP OSPF border router here. So this R1 is an ASBR, and this is the cost to reach. This is the cost to reach it, 64. From here, the cost to reach this ASBR is 64. Then, because this R2 is working as an ABR, so it will be responsible to generate a type 4 LSA. We'll inject that type 4 LSA in the database of area 1 only. You can check show IP OSPF database. So in the database of area 0, you will never get type 4 LSA. Is there type 4 LSA? Hello? Under area 1, is there any type 4 LSA? But under area 1, definitely you must get type 4 LSA. Summary ASBR LSA. What I said, ASBR summary LSA, right? So this is for area 1 only, not for area 0. So this time it has been generated by advertising router is what? 2222, which is ABR. So it has been originated by ABR, and it is having router ID of an ASBR. As you can see, even you can open it like show IP OSPF database ASBR summary LSA for 1.1.1, or you do not specify anything because it is having only one LSA for it. So you can press enter without specifying its link ID. So you see that it is under link ID, it is having an ASBR information. See, so 111 is ASBR, and what is the cost to reach ASBR from ABR?
64.
This is from ABR, not from. I mean, actually this cost is from ABR to reach this ASBR. Fine. It means that R3 will have this information. So IP OSPF, because it will receive type 5 LSA. Along with type 5 LSA, it is also having type 4 LSA, this one, right? So advertising ID inside type 5 LSA is still same. However, if there is no type 4 LSA, will it be possible for R3 to understand that who is 11111? Tell me.
No.
If there is no type 4 LSA, will it be really possible for R3 to understand that who is 11111?
No.
But with using this type 4 LSA, so IP OSPF database ASBR summary, you will see that it is an ASBR. And what is the cost to reach it? 64. And show IP route, now you see that those routes will be available inside its own routing table. However, here it is showing you 20. I will discuss it with you later on, that why is it showing you 20. Then let's move on R4. Show IP OSPF database. It is also having the database of area 1. That is why it is also having that type 4 LSA for area 1. That is why still it is having this information that who is an ASBR. Show IP OSPF border router, so you can easily come to know that who is working as an ASBR. So this is, and this is what? ABR. 222 is working as an ABR, whereas 111 is working as an ASBR. Then you can move on R5. Now because R5 is participating in area 2 and there is no ABR, there is no ABR available for area 2, and because there is no ABR available for area 2, so will it be really possible to have type 4 LSA in the database of area 2 now? See, because only ABR can inject type 4 LSA in any area. So this time for area 2, there is no ABR available. Even you can run this command, show IP OSPF border router. Does it have any information about ABR or ASBR?
No.
Now you can open its database table as well. It will be having type 5 LSAs, but because it does not have any information about advertising router, now you can configure a static route.
Why we are having only 4 prefixes? We configured 5 actually.
I think I removed one. I don't have that.
Yes.
On all routers only we are having these 4 only. It doesn't matter. I mean, one is missing. What can we do? Okay. Sri Harsha.
Even for me, it came router. Even from it came when I tried some practical, I told it. Even from one was missing. Fine.
Wait. Great. It is having some problem with loopback 1 only.
So other users
That's the reason. That's the reason. See, that's why it is not getting redistributed, because it is already advertised inside the OSPF itself. Now it will get redistributed.
Yeah.
It was already advertised in OSPF, then how can you redistribute it, right? So that was the reason. Fine. So in this way, you see that on R5 we are having type of LSS, but we are not able to install them inside the routing table. That's the problem now. Now you cannot solve it. To solve this problem, area 2 must have an ABR. And to have an ABR, of course, and this time your redistribution cannot work here.
Yes.
For these especially type of LSS. For inter-area prefixes, redistribution can work. But for these type of LSS, for these pre-existing type of LSS, your redistribution will not work. Or it can work. Okay, because you will be using different processes, so it can work. Because you will be using different processes. Let's do it. On R4, say no router OSPF 1. Say router OSPF 1. Router ID is 4.4.4. Interface S1 by 0. IP OSPF 1. Area 1. Loopback 1. Interface S1 by, sorry.
1 by 1.
Router OSPF 2. Router ID is 40.40.40.40. Interface S1 by 1. IP OSPF 1. Area.
2.
Sorry. Fine. Then after show IP route, you see routes are there. Show IP OSPF database. Type file LSS are there. But if you move on R5 now, show IP OSPF database. Check it out. Let me move on R4, check its database table first. Okay, even here process 2 must be there on R4. Okay, process 2 is there,
Yeah.
but under process 2 you do not. Okay, you are also having this type of LSS. They are still there. Means that for for external prefixes you will not require to perform redistribution, even if you are using two different processes as well. So now, because type of LSS were also available in process 2 as well, it means it will give it to R5 automatically, and again R5 will not be able to install them inside its routing table. What was I thinking actually? I thought that on R4, what will I do? I will perform redistribution like in this way: router of SPF2, say redistribute of SPF1, and then
Submit.
check its database table now. So those 190 to 168, okay, now these are given by both of them. See, 111 as well as 40. So 40 is reachable from here, so it must install them now in its routing table. But according to the database table, now it is getting this type of LSS coming from, I mean especially 191.168.1.0. I'm talking in perspective of these prefixes, right? So we performed redistribution on R4 as well, and already it was receiving them. Leo.
Yes.
So it has also proved that for type of LSS, even if you are running two different processes, it will not be required to perform redistribution. Type of LSS can move from one process to another process without any requirement of
Yes.
redistribution.
तो इसके पास टाइप 4 तो नहीं है.
There is no type 4 LSS.
Type 4 is. No,
But this time 40 is reachable from here, because R4 is working as an ASBR this time, which is reachable from R5. Yes, tell me. Age.
जो LSA एज है
Where is?
वहाँ से आ रही है, उसकी एज बहुत ज़्यादा है, तो उसका वो इंटरवल होता है, क्लास इंटरवल, उसके बाद वो रिफ्रेश करेगा ये.
Yeah, of course, after 30 minutes. In OSPF, LSA refresh interval is 30 minutes. Timeout is by default 60 minutes. Rest of the things we'll discuss in next class now. But see, we are